Hello, my name is Brock LaMeres, and I'm an associate professor in the Department of Electrical and Computer Engineering at Montana State University, Bozeman. In this video, I'm going to talk about a portable lab kit that I've developed for teaching introductory courses in logic circuits and logic design. These courses are typically found in all ABET accredited EE or CPE programs, and they're also common electives by computer scientists and mechanical engineers, so they tend to have large enrollments found in the freshman and sophomore year. The topics covered in these classes are the classical digital design approach, including number systems, digital circuit operation, Boolean algebra, combinational logic design, finite state machines. And recently, we've seen in the past 10 years a modern digital design flow incorporated into these classes. So the modern digital design flow uses a hardware description language-based approach using VHDL or Verilog, and this allows more complex systems to be modeled, such as arithmetic circuits, computer systems, and the HDL flow also allows you to have a laboratory component using programmable logic devices. So when we converted this entire course or series of courses online, replacing the lecture was relatively straightforward. We used traditional reading assignments. We developed a book for the course. We have lecture videos using a dock camera or screen capture, and then the homework is in the form of online multiple graded or automatically graded multiple choice or simulations that are uploaded to a Dropbox, and then there's also a discussion tool for interaction. But the laboratory was the challenge. What we decided to do was we desired a portable lab kit which would allow students to take the lab across our state. That meant that we wanted to have low cost as a priority. We also wanted experience with the classical and modern digital design flows, and we also wanted experience with measurement techniques and debugging. So what we came up with was a kit that consisted of three things. The first was a traditional breadboard and an assortment of discrete parts. So we chose the 74 HC series parts, which are basic gates, AND gates, OR gates, and this gives our students experience with interfacing, but the CMOS aspect of these parts means that it consumes very little power. So you can fill up your entire breadboard and you can power it off of a USB cable or the type of current you see out of a USB device. We also have basic I/O, LEDs, buzzers, etc. to give feedback of the circuit, and this helps teach the classical digital design. We also then included a Terasic DE0-nano FPGA board, and this allowed HDL-based designs to be downloaded to the FPGA and ran, and then we could interface the FPGA to the breadboard if we wanted to get access to I/O. And we used the free Quartus software from Altera to actually to perform the implementation. That gave us the modern digital design aspect of the lab. But then we also use the Analog Discovery from Digilent, and this is a USB-based instrument. They call it a USB oscilloscope, but it's much more than that, and the more part of that really enables the portable lab kit. So this device has a power supply, arbitrary waveform generator, voltmeter, logic analyzer, and an oscilloscope, and it's powered completely from a computer. So the student plugs it into a laptop, and they've got power that they can then provide to their breadboard. So that really was the key to the portable aspect of this. We developed a variety of lab assignments, and the students would demonstrate the labs using either Google Hangout, which is a free video conferencing system, or by uploading videos. So this is an example of a student that is, uploaded a video, and he's walking through changing the I/O, and then I can observe that the circuit is operating properly. And the video upload is usually when there's no problems. Google Hangout is where the students need help or want to interact. The pros of this lab kit were we've used this successfully for 4 semesters at Montana State with no major problems. The kit was fully portable, and the original cost was $185, so we kind of achieved what we thought was a reasonable price. The courses have been extended statewide, so we now have sections that have students from our local campus in addition to our Billings campus and a community college. And we are also using this for our own students to kind of alleviate large enrollments that are exceeding our classroom and lab capacity. We also are offering more sections of this in the summer that allow our students to kind of avoid prerequisite chains that they might get caught up in. The con of this approach is whenever you have a portable lab kit that uses electronics, it's going to be product obsolescence. The Analog Discovery has already gone to a version 2, and the DE0-nano board has been replaced. So the issues with the product obsolescence is keeping lab kits maintained, keeping everything up to date, and keeping the handouts and videos up to date. So it takes a lot of human resources to do that. And then the cost is always a concern on this. We had original pricing of the Analog Discovery as kind of a promotional offer of $99 when we started this project 2 years ago. Now it's jumped to $179 academic. The DE0 is also, it started at $59 and now it's up to $90 because it's being obsoleted. So they want you to move to a newer board with more functionality. So cost creep is always a concern. But in summary, the portable lab kit has enabled us to have a fully online offering of these logic courses. And over the assessment tools that we've developed over the last couple of years, we've seen no significant difference in student understanding. And this work has been supported over the past 7 years through multiple NSF grants through the Division of Undergraduate Education. And that's it.